Okay, so the next example is going to illustrate what happens if you don't have equal width. So I have 7 data points, and it says use both RRAM and LRAM. And maybe I'll just do one because I think you guys kind of have the idea here. So let's use LRAM. Let's construct left rectangles. And so, like the first one is from -6 to -2. So -6 to -2. But because I'm choosing the left side, I'm only going to go to the height here. So I have this guy right here. So that would be the height at -6, which is a height of 2. And the width of that is whatever -6 and -2 is, so it's 4. So this very first rectangle is going to be, again, the height on the left side, which is 2, times the width here from -6 to -2, which is 4, plus. And then, like maybe we can change to blue here. Then we go to the next rectangle. From -2 to 1 is my next partition. So I'm going here. -2 to 1 is a distance of 3. I'm choosing the left side, so that would have a height of 7. That's what the left side is. So 3 times 7 plus, maybe I'll switch back to red. So then I say, okay, so now my next partition is from 1 to 3. So that is a width of only 2, and I'm choosing the left side. So now I have this rectangle. So that would be 2 times the left side, which is 11. Plus, go back to blue. Oops, there it is. Now I'm going from, what is that? Going from 3 to 4. So that's only a width of 1. So plus 1 times, and if I choose the left side, that's a height of 9, plus, I'm going from 4 to 6, so that's a width of 2, and so that'd be 2 times choosing the left side. This is a height of, I think, does that say 7? Yes, 7, plus our next rectangle, which will be our last rectangle, which is from 6 to 10, so it's a width of 4, and the left height is 5. So again, if I don't have equal width, that just means that there's nothing to factor out. That means each of these partitions, so like 2 units away, 3 units away, 2 units away, 1 unit away, 2 units away, 4 units away, each of those partitions are a different interval just based on my data. Multiply, and I could certainly then find that area. Okay? I do the same thing for the other example, except for instead of choosing the left side, I choose the right. So I'm okay with leaving that as an exercise to do on your own. Now, again, we could really just extract the bare minimum, and all we really need to know is the x and the y values to construct this. Like I lose the visual, so to me you kind of have a little bit of a disconnect here, but honestly, like all you need to know is how wide is each rectangle or trapezoid and what's the height on the left side or the right side. So if I'm going to use 6 unequal trapezoids, okay, so my first trapezoid would be bound between the x value of -4 to -1, okay? That has a space of 3, and it's the average of the function values, 1 plus 6. Plus, and then I go from, I'll go this color, and I go from -1 to 1. That trapezoid, so that has a distance of 2 times 1/2 the function values, 6 plus 7. Maybe go back to blue as well, plus from 1 to 2, so that's 1, and then the average, 1/2 of 7 plus 6, right? And then we can say plus, go back to this color, from 2 to 4, that's a distance of 2, average out 6 and 3, and then we could go back to blue, plus, from 4 to 5, so I'm out of space, that's 1 times 1/2, 3 plus 2, and then last but not least, oops, this color here, we could go from 5 to 8, which is a distance of 3, and that's, 3, and we have to average 2 plus 5, okay? So yeah, again, I have 6 different trapezoids And I'm following the trapezoid formula just based on average the function values, which is 1/2 f1 plus f2 times the height, or I guess the height of the trapezoid, which is on the side now, so it's in between the two function values. Okay. Now, if you wanted to use the same, same thing, but use RAM of 4 equal rectangles. So let's think about this for a second. So between -4 and 8, so 8 minus -4, 8 minus -4 over 4. So that's our B minus A over N. I'm going to say that a lot probably tomorrow. So we get 8 minus -4 over 4, which is 12 over 4, which means I need to have everything in increments of 3. So it's the right side. So I'm going to, so between -4 and -1, notice conveniently that's 3 units apart. I'm going to choose the right side. So it's f of -1. Because between -4 and -1, -1's the right side. So it's 3 times f of -1 plus 3 times f of, well, if I already know I'm going up 3 from -1 is 2. And hopefully we have that data point, -1 to 2. Now we've got something in the middle, who cares? We need the f of 2, right? So f of 2 plus, and then again, 3 times f of, well, 3 more than 2 is 5. The next rectangle from 2 to 5, right? From 2 to 5, I don't care if there's a data point in the middle, I'm choosing 5, which is the right side. And then our last rectangle would be plus 3 times f of 8, because 8's 3 away from 5, and it just conveniently happens to be that we have that data point. So, I mean, I picked that on purpose, right? I picked these numbers on purpose so I can actually do an RAM 4. And then I calculate that value. Okay, so our last example, we have this table of values. It's 0 to 16, and I want RAM 4 equal width. So RAM 4, so again, 16 minus 0 is 16, divided by 4 is 4. So I know I'm looking for a width of 4. So the first one is from 0 to 4. The next one we could say is from 4 to 8. The next one is from 8 to 12. And then the last one is from 12 to 16. So those are 4 rectangles of equal width. But I want to choose the middle point. And it's a little bit deceiving at first because I have 2 middle points, or 2 middle points, or right, 2. So how do you know which one's the middle? Well, it's not the middle of what you're given, it's the middle of it, or, like the average. What is the halfway between 0 and 4? Oh, it's 2. So in that first rectangle, I'm going to choose the function value at 2. Between the next two, between 4 and 8, I'm going to choose the function value at 6. Between the next two, I'm going to choose the function value at 10. And between the last two, I'm going to choose the function value at 14. And if you've noticed, I'll go back to orange, I guess that's fine. Like that was not what I wanted to do. Not highlight, I want marker, pen, I should say. So notice that this is 2, 6, 10, 14. Those are all 4 apart, which was what I wanted, equal width. So once you find that first midpoint, every midpoint will have that same spacing. So then how do I represent this? Well, I could say it's f of 2 times 4 plus 4 times f of 6 plus 4 times f of 10 plus 4 times f of 14. Okay. Yeah, and that's it. And in all honesty, I could have started this chapter with just area, like this. Again, we really aren't doing any calculus. We're just looking at rectangles. And where this is leading for tomorrow is that we're going to take all those rectangles and squish them, shrink them, condense them, and make them infinitely small in terms of width. And then the idea there is that, well, what allows us to go infinitely small? And that's a limit. And so we're going to bring back limits tomorrow. So spoiler alert, watch out for that. But it's really exciting. And yeah, so try the homework, see how it goes, and then make sure you say thank you to Mrs. Olsar for watching your class today.